Okay, cool. All right. Thanks for joining the webinar. This is our second or third out of 5. I've lost track. So today's topic is getting started with the ActivityBot 360. Also in the video view, you'll see a few co-hosts. One is Kate Hay, who I work with, and she can help all the teachers get set up with the right hardware. And the other is Carol Hazlitt, who is an educator and hobbyist and engineer and activist with all things electronics from Seattle, and also works with Seattle Robotics Society. So we invite her in to keep me straight and yeah, throw some surprises at us here and there. Okay, let's get started. I recognize a whole bunch of people from the list. I'm thrilled to see you. Since it's kind of a small group, we got 30. I have a bit of a loose agenda where you can influence it as we go, and you can raise your hand and enable your mic anytime, or if you don't want to talk and you prefer to chat, you can do that using the chat tool. Just type it in there. So this is for you, and I'm glad you're here. So about the Q&A, just some Zoom housekeeping here. If you have a question you'd like us to answer, you could use the Q&A in Zoom. You'll see it, it's a little button in the middle of your control bar. Or like I said, you can use the chat window and raise your hand also, and then you can actually talk at any time you want. We do webinars a little bit crazy around here at Parallax, and what do I mean by that? We don't hide behind a PowerPoint slideshow. We do some programming. We have robot demos, and things will often go wrong, although there is no fire shooting robots in today's webinar. But aside from that experience, you'll expect a few surprises. Here's our agenda. First off, the introductions, which I've done, and the bulk of our webinar will be about the ActivityBot 360. I've identified the main pieces to talk about here, but you are free to divert or ask me to expand on any of them at any time. But basically, we're going to go over the hardware, the programming environment, the tutorials, the assessments, and then your very important role. And then finally, I'll show a few other projects with the ActivityBot 360. We have some fun things here as well, like this. Okay, everybody always likes that. And some robots with color sensors on them that we will demonstrate. Oh, by the way, isn't this cute? Okay. And then we'll talk about support and then our upcoming webinars. If you like what you see, I really want to have you back for the next one. So if you're new to Parallax, this is our company. This is our team right here. There are 30 of us here. And we do everything right here in Rockland, California. We do the manufacturing, design support, sales, answer your questions, answer the Educator hotline when you call us. This is our team. This is our manufacturing facility. And we do entire electronic surface mount, through hole, and CNC machining, and laser routing, and well, all that stuff. What we're about. It's always fun to describe Parallax to people who are kind of new, and the easy answer is, well, we make robots. But those of you who know us know that we do all kinds of things. We've actually fabricated our own microcontroller, which is the Propeller multi-core microcontroller that is at the heart of all of our systems. So that's kind of a semiconductor company function. But our main business is in education, and our most popular products are robots for schools, and we get really activated internally when we see our students getting turned on and our teachers getting it and moving on to the next step. So our program is about programming microcontrollers with a big emphasis on electronics. And we believe in learning by doing. So we're very much a hands-on company. So at the core of everything I'm showing you today, and this is a little bit technical, perhaps not if you're already using the Propeller, is our own chip, which is the Propeller multi-core. This is a true simultaneous processing microcontroller. and our robots take advantage of what it can do. It's in the middle of this board, and there are a whole bunch of other goodies in this board which are really best learned by discovery, but they do everything from RF communication to audio amplifying to convenient headers to connect to sensors and motors. There's an A to D converter. It goes on and on. What makes us unique is we really pick up where other robot education products leave off. That is, our products are intended for commercial use. And we saw a lot of chips into real products like this one right here. This is the life-size Bud Light Pac-Man commercial that filmed during the Super Bowl a couple years ago. And these are actually roller skaters, and they're carrying a very powerful string of LED lights that are all serial addressable. And they're controlled over XP. Then there's this kind of boat. This is the New Zealand Emirates America's Cup boat, which has 30 of our devices in it. And those are high profile, easy to talk about. Most products were kind of hidden in, built into the circuit board. So let's jump into the ActivityBot 360 educational system. There are really 5 main pieces to this. And we're going to talk about them in this order. The first is the ActivityBot 360. That's the actual robot hardware. And then the second is the programming environment, which is a dual Blockly and C path. And the third are the tutorials. And then fourth is support material. That's all of our educator resources. That includes things like assessment tests, standards alignments, teaching tips, etc. Or if you're in the state of California, then you have access to our UC-approved program, which is a transferable elective. And then fifth, of course, the student and teacher, listed in no particular order there. ActivityBot. So it comes in a box like this, and it looks like this. And that box is a convenient storage container. Here's another reference size video. This is my cat, Fluffy. So robot projects, you put them on Twitter, they're interesting. If you add a cat, your views go up by 10-fold. So that's my tip for you. Just add cat. The hardware looks like this. So you open up the box, there are a whole bunch of parts. One of the most common questions teachers ask us is, how long does it take to build? So this robot probably takes about 1.5 hours to 2 hours to build, as you see it without the components on it. And so all the components, which are all the parts in the lower right-hand square, are used for the project. But I think you're in for about 1.5 hours, and from there, it's all about customization and applications. So you'll notice a lot of slots and holes on the chassis, and these are for things that we make, like grippers, line followers, or whatever. Like Carol prints a lot of 3D things and might use these locations to mount. And these are 440 screw sizes, which is the smallest size you can buy at most ACE hardware stores. And then here's a built-up fleet of them. Those are some of my robots doing different things. So at the heart of this, and if you're new to robotics, the word encoder is kind of an unknown, but this is a servo which we have produced, which is in the ActivityBot 360. And you'll notice that it looks like a standard servo, but it has an additional yellow line that comes out of it. Okay, that's a feedback line. And our libraries manage a complete control loop so that when you tell this robot to go straight, it can read the Hall effect sensor in the motor and then adjust the speed so the robot actually goes straight. And this is not important until you really live without it, then you realize how important it really is. Because it's really hard to have a group of students working with, say, a maze or a task where they need dead reckoning, and they can't get their robots to go straight, and they can only rely on sensors. Sometimes you have to have reliable dead reckoning. So this is one of the hardware features that's part of our ActivityBot 360. And there's a very powerful library that Andy produced. I think a lot of you know him from all the books he's written. He's one of our stars here, which makes good use of the servo. So for people like myself, this boils the servo down to one line of code. Go straight, 100 centimeters, boom, every time. Programming environment. For the ActivityBot and for all of our educational products, actually, with minor exception, we have a dual Blockly C system. And I'm going to start just by showing you the Blockly system. And we'll do a little project because everybody likes to program. Of all the classes I've done, the teachers, they really want to program. They want to see and feel and touch the system. And it's so fun when you hear it click and your code snaps together. So we're going to jump in and do a project together. So I'm going to switch over to Blockly. And I have a blank project here. So what I've got is an ActivityBot that has a ping sensor on the top, okay? And I'm going to do the same thing that we do in our tutorials, which is we do subsystem development and then testing, and then we add the robot to it. So the purpose of this is just to get familiar with the environment. So I want to make this sensor talk, and it happens to be one that's on our list. So I'm going to grab that block, pull it out, and I'll decrease the size a little bit so I can build a little bit of a program. And it wants to attach to a variable, so I'll get one. By default, all variables are named item in Blockly, so I'm just going to rename it to distance. And I'm going to put this into a loop because I don't want to get the value one time. I would like to retrieve it over and over. And then I would like to print a graph. So here under communicate, you can grab a graph block. And if you hear that clicking, that means things are made to go together. And I'll drop that in here. And you'll notice this little exclamation point warning you must use a graph initialize block at the top of your program. So we'll get one. And I'm going to limit this to, since I'm using a ping sensor, I want to test it first. I don't want the graph to be skewed by readings of 120 inches. So I'll just limit it to 40 inches. And the pin that I have this on, maybe you can all see that, must be pin 7. And then for good housekeeping, we'll throw a little pause in here. How about 100 milliseconds? And I think we're ready to download. So now we go out to the Parallax Cloud, Amazon Web Servers. Will return a program to us, usually. Maybe except this time, we'll try that again. Give it just a minute. Okay, nothing really unique. And just give this one more shot, then I'll move on. Let me know when you see those blue lights on there, Kate. No one looks so worried. It's a demo. Sometimes things break. Okay, not going so well. All right, so anyway, the purpose of this program, you might have to build this one up, Carol, and screen share it, is really to show how easy it is to build a Blockly program. So once you've dragged some blocks out and you want to see what they do, you can click on them and then go straight to our reference for that block. So click Help, and this will take us to the reference for the ping block and explains how it works, and then even in some cases it gives you a wiring example. So very useful to have. Okay, so in C, the most common question we have after they see this is, okay, what about the C code? You can click on the code button, and then here it is. And you should be able to copy that right into Simple IDE. So I'll switch my screen sharing over to that now. and then I'll paste it. And from here you can download. So looks like you had a little bit of an issue with builds and things, but I'll not worry about it for now. So, okay, moving on. Any questions so far about what I've shown you in Blockly? Okay, all right, good. So if you're new to Blockly, I will be forwarding you a link to an article I published. What's so unique about what Parallax has done is we have combined a language which has mainly been used by small children. And it's in the category of visual programming languages with Scratch, Snap, and Blockly to learn programming. But we've coupled that language with a very capable processor, the Propeller multi-core microcontroller. And so it's a funny fit. And for higher levels, like in university, it means students can get their projects done really, really quick. And the Blockly code is like a super pseudocode that has commonalities in it to all languages. For example, control operators, values, arrays, variables. This you will see in most all languages, regardless of BASIC, C, Python, or whatever. And then Parallax's menus are all very much customized up top, but mainly down below. So under sensor, you'll see a variety of devices that we make. And if there's not a block for it, you can likely still talk to it just by going into communicate and then protocols. For example, if it's serial, here's how you get to it. Or if it generates a pulse width, you can get to it from here. Okay, so there are multiple ways to do anything. Then the robot is supported by these blocks.
Hey, Ken?
Yeah.
I don't know about other attendees, but I'm still seeing
right.
your simple IDE instead of your Blockly.
Thank you. Yep, switched over. Okay, now we're
There
back.
we go. So if you could repeat that about finding the sensor blocks and so forth.
Yep. So the top part here is actually predefined by Google. And this is common to all programming languages, controls, operators, variables, functions, etc. Parallax has customized and expanded this whole system with these bottom menus. So for example, under communicate, there are a whole bunch of ways you can communicate with your microcontroller. You can use graphing, displays. There are protocols for serial, asynchronous, for LCDs, and then for terminal, and then also for RF communication. And I'll demonstrate to you a few of these things in a minute. So if you don't find a sensor block, that's okay. You might be able to get it under the analog. If it's an analog sensor or a pulse in, you can usually interface to it this way. And the ActivityBot 360 has a set of blocks. It's on the bottom of the list. And these would be them. So yeah, you have in this dead reckoning blocks. For example, we'll drag a few out, just get a quick look while we're here. Okay, so with driving distances, you can drive ticks. There are 64 ticks per revolution, or centimeters or inches. And then you have full speed control as well. And all of this is handled with our encoder system in the background with our library. So we'll forward you this article so you could read a little more about Blockly. The tutorials. Okay, so we have two sets of tutorials for the ActivityBot 360. They are in C and in Blockly. They're parallel and very similar. Parallax focuses on circuits, coding, building and testing subsystems with real electronic components. So we'll go take a look at this, starting with about the Whisker tutorial. So to get to them, you just go into learn.parallax.com and click on the ActivityBot. And we'll focus on the Blockly path. So these two paths are the same. And let's look at navigate with touch. Okay, so through all of our tutorials, you will see a series that happens in the following order. First, we introduce the topic, sometimes with a video, such as this one, which has the whiskers. I'll just jump to it, there you go. So they can see what's going to happen. And then we demonstrate how to build the circuit. And you will see in all of our tutorials a physical layout, what we call a pictorial, and then a schematic. And the idea is to really lead them towards the schematic and get them thinking in this way. So after you build the circuit on the board, then you can test it. So here's some Blockly code, which just tests the whiskers on this type of robot. And you see the values that you get on a terminal. And then we jump into try this, your turn. And all of this has supporting assessment material I'll show to you. So the next step would be, okay, let's make the wheels move when you touch a whisker. That's what this code would do. We explain how it works, that it's just a simple push button circuit. And we have the student try it. And then ultimately, we're building on building, we're roaming. So that particular project just looks like this. I'll switch over to, actually, I think you can see it on my camera. So this is just a whisker feedback. It's a great first circuit to build. That's how it looks. And the physical placement of everything is important. It's just a push button, high or low. So after that, we move on to ultrasound, and it's built very much the same way. So you'll see the pattern repeating. Build and test it, and then how to roam with it, and then measuring distance. This is one of my favorites, which is navigating with visible light. So I've got that circuit built up on this robot. So 2 photoresistors pointed out to the edge. Got a nice powerful light, but can we overcome the outside light? I don't know, we'll find out. So this is a lot of fun to do in class. What you can do is program a number of robots like this, but put obstacles in the way and have them find their way out the door. And all it takes is one window being open, and that is so much more powerful than the lights you'll have from flashlights. Like you see, I'm trying to fight to get it back here because it wants to go outside. How'd you like that? Okay, so moving on, let's look also at the infrared circuit, which is this one. This is one of the more famous parallax robotic circuits, and choosing IR emitters to generate light, and then a receiver receives that light, and it works up to about 2 feet. So one sensor never serves every purpose. Sometimes you need touch, sometimes you need infrared, sometimes ultrasonic is good, sometimes you even want a laser. And all of these are supported by our hardware. So this particular build looks like this. And students normally, to be honest, will get this wrong, or maybe half of them will get it right the first time, because there are a lot of things you have to pay attention to when you're working with real components, that you have the LEDs in correctly, that you've wired the receivers properly, that you're using the right size resistors, that you're not shorting power and ground. There's a lot of room here to have problems. And this is important for students because it's the first time for most of them that they can really experience real engineering and some of the frustration that goes with it. While electronics is very flexible to us, it's also very exact. So if you don't build this to match the code with the right components, it will not work. So this would be a wireless version of whiskers. So here's my built-up version. Let's just see it work. So that same circuit could be made to work with remote control, or you can point those the components down and detect the edge of a table. So there's a lot of fun there, and it's very similar to what would be in a line follower, like this. So infrared is a powerful and simple robot sensor. Did I miss anything on those tutorials, Stephanie?
Well, just the IR remote activity is there, so you can build a little user interface to your specifications with a remote control and have the robot do different behaviors based on different numbers. So that's available.
And I'll show that too. Thanks for reminding me on that. So before I go any further, it has to be pointed out, I work with a lot of really capable people. These are a few of them that I have retrieved off of the internet who actually have pictures available. But if you haven't met them, that's Andy, upper left, and that's Stephanie. And then there's, on the lower is Matt and Miguel. And this year we've been super busy teaching a lot of classes. So it seems like I only see any of them every 2 to 3 weeks. But all of us at Parallax are a bunch of people that make this whole system go. They're IT people, people that support Chromebooks, Mac, Apple, like Jeff, and we've pretty much got it all covered internally. So we have the whole system inside. I want to point out the reference guide again. If you click on any block, you can get to this, and this is very powerful. We do a pretty good job, I would say, keeping it current with the Blockly that is visible to our users.
Yeah. Can I add something?
Please. Yep.
When I first took the BlocklyProp class from Matt, he used that little experiment you just did with light following. And at the end of the class, he had everybody put their robots on that program. And we turned off the lights in the room and opened the door to the classroom, and all the robots went in a line out the door. That was really fun to see. It was really fun to see.
That sounds fun. I love it. Mass robots.
It looked almost like they were thinking, because they were all doing this herding behavior, going towards that door and then on out the door.
So let's talk about the assessments and the scope and sequence and the standards. So this is all teacher material. I'm going to show it to you first, and then I will show you where to get it and tell you how to go about getting it. So for every one of our tutorials, there is assessment material you can download, and it consists of questions and answers. And it looks like this. This would be for the whiskers. So this corresponds very closely to the whisker tutorial and has some questions, multiple choice, true and false, and the electronics that we introduced. Code examples. And then the answers for the teacher, the answer key. So there's a whole series of these for C and Blockly, and they are kept current. This one is 7 pages for one of the activities. Also useful is this: if you are needing to show that you are standard compliant, we have a 27-page document that looks at all of our small robots. That is actually the BoBot, the ShieldBot, and the ActivityBot, and identifies which standards they correlate to. So we're using Common Core state standards for ELA, math, the NGSS, the K-12 computer science framework, and CTE standards, and the 21st century competencies. It's no wonder teachers have trouble keeping all this straight. This is something else. So that's available. And then the third thing is the scope and sequence. So how do you actually teach this in a class? This is another document that you can download and identifies for each unit that we offer, how much time do you need to teach it, and then what is it about, what skills are achieved, and what resources exist for it. So in some cases there are videos, there are other tutorials, or the reference guide. So we identify all those for you. And it works out that if you go through everything in class, you're probably talking about, I'd say for the basic ActivityBot, around 30 hours if you did the tests and everything. So where do you get these? This is where they hide. You come into Learn at learn.parallax.com, and then you click on Educators, Educator Resources, and then under ActivityBot Resources, you will see this. And certain things are shown for everybody, but additional things are shown for anybody who logs in. So if I log in, and then I come back in here, now suddenly I see the assessment material for Blockly and C, and then contest ideas, and then some things that are publicly available as well. So the way you get this material is by sending us an email. And we just want to see that you're an educator. So send an email to learn@parallax.com from your school or college address, and then we will let you in and give you a link. It's that easy. So the most important part of this really is the students and the teachers. You know, robots are a great way to get students really motivated. I've been to classes where these come out and the students stay in for lunch and just keep working until they've done everything they could possibly do and they need more parts. This is one student who I ran into last week in Chicago who just got introduced to this and really took off on her way. So I say give them the hardware and then let them go. It helps as a teacher to have some basic understanding of certain things like where the software is downloaded, troubleshooting techniques, this kind of thing, which we teach in our classes or you could really learn on your own. Oh, might as well get a look at this from a student viewpoint. So this is a video we collected at a nearby high school. Let's see what this kid has to say. And it may be that the internet here is lagging, and that's why I was unable to download to the ActivityBot, but that's okay because we have an offline version coming soon. So anyway, yeah, we aren't going to be seeing that video. This year, we're teaching 500 educators how to program our microcontrollers, and we are about 425 out of 500 through that process. And today we are running classes from Texas, and we have a few more weeks, and then we're done with it. But it really shows our commitment to education to help the teachers get started. This year we put it all in, and I don't know of another company that has done that like we have. And this particular class is the one that kicked it off. This was in New York City last year, New York University, where we had classes that were previously paid for, $250, but we made one free, and suddenly we had 50 teachers in it. So that started the trend of making them totally free. And as I mentioned, our class circuit is coming to a close in the next couple of weeks, and we haven't decided yet what we're doing for next year. But they're a lot of fun. Teachers, you're just like students. When you get into this, you get down the ground, you crawl around with your robots, and we just let you work and build. So let's look at some more demos. Might be kind of fun. So these are additional things to do with your ActivityBot. So the first thing I've got here is, let's do the color-coded line follower. So this is just a line follower, and there are at the intersections, red, which means turn left, yellow, turn right, and then these are green. It's hard to tell with the lighting. Green means turn around. And the robot that I'll place on this is a standard ActivityBot 360 with a QTI line follower circuit and a color pal in front. And this particular program consists of real-time speed control based on the line follower sensors, And then when it sees a color, it switches over to a dead reckoning to turn right or left. Earlier, this was getting a little bit flooded with my lighting coming in from the outside. So let's give it a shot. I'll close that blind for us. Okay, green is turn around. Yellow is right. And if you notice too, you'll hear the sound, which is happening simultaneous to the sensors and the motor control. And that's possible because we're using a multi-core microcontroller. Blockly has a block called new processor. And you could put a function in that block. And in the new processor block, I'm using the audio out to generate sound. So occasionally it has a little bit of trouble differentiating yellow from green. But of course, the environment you design has everything to do with the success. These are the colors I found at Ace Hardware this morning. I didn't have time to adjust it. But on my other setup, it could run reliably all day. Put that aside. Here's another neat one. This is the ActivityBot. This is one of the stars in our office. I could see Carol likes this. I think she's built something similar.
Mine was a big butterfly.
Turn on the speaker. Plug in the power. And let's see what the ActivityBot does. Okay, so the ActivityBot is doing something you wouldn't see commonly on small robots, but it has a SD card in the back, and on that SD card are WAV files, and I think these might even be on our website. You can download and put them on, and then with one block, you can start that WAV file and play it back through the audio amplifier. And that's being done on one of these portable speakers. Isn't that fun? Okay, kitty. All right. So we'll turn that robot off. Similar application. This one's using infrared. So it's a ultrasonic sensor on a servo scanning and a speaker again connected to the audio amplifier. And it has an infrared receiver on it to start it on the top. So let's see what it does. Oh, it helps to turn it on. Okay. So it's a very capable roamer, but additionally, it can play songs. So these are entire songs which were converted to WAV files and then saved on the SD card. So you just press a different button on the remote, and then you can get a different song. So that's a lot of fun. And finally, here's a neat one. So who wants to guess what this one does?
Well, they talk to each other.
All right. What else?
There's a tilt sensor there.
Okay. Okay. So we have a 2-axis accelerometer on one, and then an XB controller. All right, so this program was written entirely in Blockly, and I don't think you'll see any Blocklys that also do RF like ours does, but this is wireless control, and it's a tilt controller. So this is my remote, and then my robot, so that when I tilt it forward.
Oh, you're driving the robot.
Yeah.
I was trying to think of what a seismometer would have to do with a robot.
Okay, so in this case, the program It's actually quite simple, but basically you're reading the sensor and then you're sending out over RF three bytes probably, or I would say three variables. And the first one is an exclamation point, and then the second is the Y tilt, and then the X tilt. And then you turn those into drive commands on this robot. So some of these I think are published in C, maybe all of them are, and we're working towards getting them published in Blockly. And by the way, this is the laser ping, and you can use it in lieu of the ultrasonic ping. So simply remove the ping, and then you can drop in the laser, and it will work the same way. That's a new block we just added. The Educator Hotline. This is a live person hotline that you can call anytime and just get one of us. And why does this matter? Well, I'm also a CTE teacher. I've been in class, and there's nothing more deflating when things start going wrong or you just have a question and you want it answered right then. If you call the Educator Hotline, you will get myself, Kate, or Matt in human form. And we can answer any question you want or else get you help. So use it. It's been very popular. Another neat place, oh, well, before we go to Facebook, we'll talk about this. I mentioned all the sensors that are supported in Blockly. This is really what our system is about, is the projects you can build with it. So just poke around in Blockly, and then you'll come up with some ideas. So how do you get started? This is my favorite way. If a teacher has plenty of funds available, I would suggest they get the ActivityBot 360 class pack. So this is a dozen robots, a dozen line followers, and then a dozen infrared remotes with rechargeable batteries. Okay, and this is something we have on sale. And if that's out of your budget, which is pretty common, you can just get the...
Wait, there's more.
Oh.
You forgot in your list that there's also a dozen of the ping bracket and turrets included in there.
Oh my gosh, look, that's this row of hardware, second from the bottom.
Yep.
Yeah, this is huge.
The batteries and chargers were chosen so there's enough batteries to have one set in your robots and one set on your chargers at all time, so you're never stuck and can't go forward in the class because your batteries have run out.
So the additional parts you would get would be the line followers, and then the ping bracket with the servo, and then the remote controls, which would be this, and the rechargeable batteries. Now, if you already have one of our other smaller robots, like the BoBot or the ShieldBot, you can upgrade to an ActivityBot 360 by buying these parts. So it consists of the propeller activity board, the 5-cell battery pack, and then the motors. But what you're not getting here are the components, but you can buy those separately as well. So this is a very cost-effective way to turn an old robot into a newer robot. So in the picture, we're showing you the ShieldBot and the BoBot. With this kit, it becomes an ActivityBot 360. So we don't like to obsolete hardware on our customers. We've been doing this for 20 years in education, and we are sensitive to things not getting used or being obsolete because we know what it costs to outfit a class.
I should look into that for the Seattle Robotics Society. When I first introduced the ActivityBot, we've been using the Arduino Shields since I started the classes. Everybody wants now the ActivityBot. They all want to switch over to the ActivityBot.
Well, thank you. We welcome them. There is another alternative too. If you don't want to get into robotics, I'll just briefly point out, this is a $30 solution. This is the Flip microcontroller. So it just plugs right into a breadboard, and why not? This is a great way to go. It even has 2 LEDs on it, and the pins are totally exposed, not attached to anything. So I favor that too.
Hey, Ken.
Yep.
There's a question from Todd in the Q&A screen. Do you see it?
Let's get a look at that. Okay, well, you got us there for sure. So the question is, do students have a hard time finding each other's shared code? Is there any way to sort or search public shared code? Not yet. We are looking at replacing, we have a prototyped search tool that's a little bit better that we will be dropping in at some point, but it's really not very functional. Probably the best thing they can do is the following. Just share the project number like this. This is common in our office. So I'll say it's project 36,300, and you can type that in right now and get to my project. But what he's referring to is that in community projects, there's a long list of them like this. And at the moment, there are 36,000 projects in this database. And you can see people getting creative, like, look at what Stephanie did. She stole the underscore because she knows she can find her stuff at the end.
Thanks for the tip.
Yeah, and that tip came from where? That came from her colleague, Ken. Anyway, good job, Stephanie. So if you're on social media, I recommend this group as well. This is Blockly for Microcontrollers. Here we welcome all microcontrollers. There are some Arduino Blockly users on here. But it's mostly all Parallax. Great place to get support and talk to other teachers.
And here's one of the things you can do with that wonderful flip.
Tell us about that robot.
This is an RC truck. It's a Mind's Eye chassis, and it's a pretty much standard RC, except for the Mind's Eye parts. It is an autonomous truck using the flip microcontroller to run it, and I'm going to add GPS unit to it pretty soon in order to make it find its way by GPS. And I also have a tugboat if you want me to drag that out.
Grab your tugboat, and then we'll talk about our upcoming webinars because it is interesting. So what Carol just showed off and where she's headed is to do some GPS navigation in Blockly. And that brings us to the subject of a future webinar, which is real-world Blockly projects, or I like to call it BlocklyProp isn't for baby programmers. And in this webinar, we'll be demonstrating real commercial uses of Blockly. We didn't totally expect this, but we're not surprised. We're now seeing commercial products being developed with our Blockly system. Why not? It's as good as the code it generates. And in those projects is one of mine, which is a GPS navigated boat, which is not navigating yet, but it will be soon. And then the other is a quadcopter that has an aerial pollination system. So we'll be looking at both of those in the next webinar very closely. Did you find your boat, Carol?
No, it's in my husband's workroom because I don't have much storage in here.
Oh.
And I can't stand up and go get it because I'm only dressed from boy stuff, kind of.
Your shop is amazing.
Oh, yeah, it's full of stuff. There's airplanes hanging over my head and all kinds of stuff. If anybody wants to see it, there's many videos and pictures of it on the web or on my YouTube channel.
Okay, perfect. And then coming up in May, we will have advanced projects with the ActivityBot 360. And I hope to really look more into the code at this time with a new computer. So that's at the end of May. There's a question. So Jerry Wang asked how students get AG credit using ActivityBot. So the school has to have a program that uses our system, and as described on the University of California and CSU transfer website. And as I understand it, they take our material and then they have the class approved by whoever does that. I don't know if it's the district or the Sun in San Diego, and then it qualifies as a G elective. So question is, can we figure something for senior folks? What do you mean by that? My dad programs in Blockly. He's 82 and he's doing it all the time. So I say jump in.
Now I'm 71. Your dad flirts with me sometimes.
Yeah. Yeah, he's a hobbyist. Last night we were working on his temperature humidity project. So I want to entertain any questions you guys have. You could enable your microphone, ask us whatever, or you could type it. Carol, can you get us a link to your YouTube channel?
Okay.
Somebody's asking for that.
Okay.
So let's see. Melanie, you asked about color following with the Scribbler 3. Well, yes and no. So it's a little bit complicated. There's not a block for it. If your students were kind of the hacker sort, there is a way to make it work. You have 3-pin connections on the Scribbler 3. You would actually have to open up the color blocks in another board type, like the Propeller Activity Board, and then download them as SVG files, and then go into a Scribbler project and then import those blocks. And then you would have access to the color PAL sensor. And yeah, you should be able to do it. I haven't tried it, but I've seen one of our customers do all kinds of crazy things this way. You want to control with a Bluetooth joystick? Let's see. Stephanie, maybe you want to answer that. It should just be a Bluetooth device, should be a serial device.
Yeah, so we would need, Bluetooth is a specific protocol? Is it not? I wonder if we'd put the Bluetooth module on the breadboard of the ActivityBot and bring it in that way. It's not something we've done.
We haven't done this.
But now someone's going to want to try.
Yeah, exactly. So we have a device for it, which is this. And we should be able to talk to it because it's a serial port interface.
Mm-hmm. And we can just use the standard serial blocks.
Oh, okay. And so Tom asked, he said, senior stuff is important, maybe voice recognition and GPS and voice synthesis. So one of the things you can do with the ActivityBot is make it play back sound files quite easily. And that might be useful instead of using a visual feedback device like a little LED, OLED, or LCD. Hope that answered. Yeah, you bet, Tom. You're welcome. Yeah, so any other questions or comments or input about where you'd like to see us take this? Some of the things that lie ahead for the ActivityBot is we are preparing an offline version of BlocklyProp. That's coming soon. And I think we do have now wireless programming, but we've not talked about it too much because we've been so busy.
We do have a question about I2C communication.